Okay, so today we're going to talk about the network layer. We're going to cover the topics of IP addressing, routing, multi-segment communication, ICMP, ARP, DNS. So I know multi-segment communication DNS is not exactly a part of layer 3, but there are going to be some topics we'll cover which are going to be essential to it. So let us get started with IP addressing. Or actually, we'll talk first about what exactly is the network layer, like what does it do? So there are a few keywords. If you understand, you will ace this question. So what is the primary function? So what it does, it transfers data in the form of packets from the source to the destination across multiple networks. It could be one network, but usually it's multiple networks because the world is so vast and wide. We obviously cannot just accommodate all of the devices, everything under one network. So multiple networks. And it does this using the help of IP addressing and routing. But for this, you just need to know that it transfers data in the form of packets from the source to the destination across multiple networks. See, it's easy. Now let us go on to the first topic, which is IP addressing. So, I know we all have probably, in the previous video we talked about IPv4 addresses in detail about the classes. There are different types of classes it belongs to, and we can identify this by looking at the first part of the IP address, first octet. So there are four octets. So what IPv4 here we're going to talk about is just the characteristics that it is 32 bits long and it is represented in the decimal format. It has four octets, and IPv6 on the other hand, it is 128 bits long and it is represented in the hexadecimal format. It is a much larger and vast network because obviously so many combinations can be made. And the need for IPv6 arrives because IPv4 it's almost completely gone, it is almost exhausted. So that is why we have to bring in IPv6, which has a much more larger scope for unique IP addresses, right? So now we are going to having this knowledge. It's just the characteristics, right? Just the characteristics. um, what it does is, however, it focuses on the job of routing data in form of IP packets from the source host to the destination host, and it doesn't concern itself with physical transmission. Okay, no physical transmission. It's basically in the form of IP address from source to destination. Moving on, we're going to talk about routing, right? So routing is basically the process, okay, of why it's needed is the process of transferring a packet from one network to another on the basis of destination IP address. So now suppose we have host A and B. We have the source and we have the destination. But how exactly we have the data packet also. How exactly will it go like this? Will it go like this? Anyway, it could go in any of these three ways, suppose. So how is this done? How is this path mapped? That is done by routing. It is the process of selecting paths in a network along which it sends its network traffic, it sends its data packets. And that is why a key component in this is basically it is path determination. This is the process of selecting a valid next hop. So it's a dynamic process, right? There are already so many maps, there are already so many paths given, but to choose the next valid hop, to choose the next valid or best path is done by routing. It's a dynamic process. Suppose if this is blocked, then it will go for this first. But if it is blocked, it'll go for this path. But if that is blocked, then it'll choose this one because it's the valid next hop, right? So, in dynamic path determination, routers are continuously exchanging information about network conditions and updating their tables accordingly. So, it has its database, it just has to dynamically map and send the data frames, send the data packets accordingly, right? So, this is what routing is. It's a very easy concept. Now, we're going to talk about IP characteristics. I just talked about IPv4, IPv6, how they are built in very little, in briefly rather. So now I'm going to talk about again addressing, data encapsulation and fragmentation, address classes, and quality of service. So addressing. each device, you need to know that each device has a unique IP address. Now, this is unique IP address in the sense in the public network. We're going to talk about a public, a much broader scale, not your home laptop, which is like private, I assume. So, each device on a network is assigned a unique IP address which identifies it within the network. It's a unique IP address. It is yours only, it is that device's only, and it identifies itself within that particular network. So, it's easier for the destination and source, it's easier to map and to send data. That is addressing, as the name suggests. Now, data encapsulation, right? And fragmentation also. So, what it does is that this data, it or rather IP in general, since we're talking about IP, it operates on this packet based model. So, for example, if you're ordering, say, a good analogy would be if you're ordering, say, a couple of toys from Amazon, so it doesn't just send you the toys, right? It wraps it in bubble wrap, say, or some brown paper, or gives you it in a neat package, a lot of packaging material. So, this is what this is IP does as well. It doesn't just send the data, it encapsulates it into its packets, and it sends it like that. Now, sometimes, say you've ordered, say it's a very big request. Okay, it's a very big request, not Amazon, just IP I'm talking about. So you want to send a lot of data, or you want to upload something, whatever. It's a lot of data. Then what this does is that it breaks it down into chunks. Okay, you're sending a lot of data, it breaks it down into chunks, which also have their own connections as well. So this is, it's connected, but it's breaking down them into chunks, and then sending them across those, routers or paths, and in the end you still get your data back. Okay, so it formulates, or it assembles its data structure, the same data structure as you have sent it before. It basically arranges it again, right? So that is this process. Okay, this process, in case the data structure is it's too big, this process is known as fragmentation, and the process of encapsulating it into capsules, or packets, that packet model, that is called encapsulation, right? So this is, these are the ways, this is a characteristic of IP. The next one is address classes. So it is important to note, I mentioned this before, I mentioned public, and you're like, what is public, what is private? So what is public, what is private is that every public IP address is unique, but private addresses could be the same. They're private, they're confined to their own private network, in the sense, suppose I have a laptop. Okay, my laptop, and I have another laptop, two laptops, same. Those will have those could have the same IP address, but they're attached to this router. This router has a public IP address, or it is attached to another router which has a public IP address, and that is how it communicates with those. It communicates with the ISP, or it communicates with the servers, and that is how it sends a request. So my laptop sends it to, say, X or a router, and this communicates, say, to another. It goes on and on. This could also be private if this is public, say. Then when it communicates, when I send a request, it receives it back, it receives to this, this router, and then the router sends it back. However, mine, it does not directly communicate. My laptop does not directly communicate to the server. It communicates to the router, which then communicates to the server. So, private bases are used within local networks and are not routable on the internet. They are not connected directly to the internet. Their requests are sent to a middleman, you could say, a router, which then is, present in the actual network on the internet, and that's how the requests are, you know, exchanged, and the data is exchanged. This is private, right? Public addresses, such as the router, the middleman I was talking about, that one is a public. It has to have a public IP address. Those are routable on the internet or in the network, right? So you should also note that 127 dot 0 dot 1, this is a loopback address. Okay, this is not part of any, private public. It's the device's own address, which is reserved for loopback. What does that mean? It means that the device is used using this address to communicate with itself. It's a loopback address. Not relevant, but I just thought you should know. Quality of service is a very general, point of it's a very general characteristic. If IP supports these mechanisms, quality of service, it prioritizes some particular data and ensures that you get the best service possible. That is, you get the best, most efficient way. It could be time sensitive data is transmitted with minimal detail. Delay is minimum. So this is quality of service, that characteristic. Now we're going to talk about ether type. Ether type is I wanted to use this as an example to explain data encapsulation more prominently, to give a better understanding of this concept. So I'm using ethernet. Yes, I know it is present in the data link layer. Also, we'll just call it layer 2. It is present in layer 2. What So we're going to just go back to our concepts of layer 2, which includes layer ethernet and MAC addressing. So briefly only. So for example, ethernet. Okay, ethernet, it also sends data, right? But it also has a frame. This is the payload, this is the header, this is the trailer. So ether type, what ether type does is that is a component of this frame header that specifies the protocol encapsulated in the frame's payload. So this probably has some protocol, right? What protocol? Say it has IPv4. So what the ether type does, it is present in the header of this is the ethernet frame, by the way. Ethernet frame, it is this ether type is present in the header, and it is following the source and MAC addresses. So the source and MAC address is also present. It is just after that. And what these are this does, it basically specifies which protocol is used. So it is sort of like an indication ki, okay, fine, this payload has IPv4 protocol or IPv6 protocol, whatever. And how is this represented? Like, how is it, saying it has IPv4? How is it represented? So this is represented in the hexadecimal format. That is how it is written inside the IP Ethernet header. So this is just a brief example. Okay, and we're going to move ahead. We're going to talk about multi-segment communication. Okay, so what is multi-segment? So we have talked about, okay, coming back, we've talked about IP addressing, we've talked about routing, we talked about path determination, but how does it all come into play in a multi-segment communication model? So single segment is very easy. Single segment and multi-segment. Another, easier way to understand is multi-network communication model. That is a good one. It's better than saying multi-segment because you get a better understanding of what you mean by segment here. So if I want to forward a packet, it could directly be A to B. This is the most simplest, communication form. You have your, say here I have my source and destination, and I also know, okay, it's directly destination is B, sent, done. But we have but the world is so huge, it's so vast and wide, we need to have a lot of networks. It cannot go directly. It is not as easy as it looks. So if I want to send it from A to, say, host C, okay, I have my source and destination, I have my data packet as well. Okay, everything is there. Now what I'll do, these segment A, segment B, and segment C are basically networks. Okay, know that we know about networks and subnets, right? So think of it like this as well. This is segment A, segment B, and segment C, which are three different networks, subnets. So I have my source, destination, and data packet, everything I have, and I'm sending it. Okay, everything is, you've packed it into your frame in your data packet, you're sending the data packet. Now it reaches router 1. Router 1, what it'll do is it'll check the destination IP address. It'll say, okay, fine. If suppose there is another one which is called segment C, and it goes to router 2 as well, it will choose the best possible path. It will route, it will see, it works dynamically. Okay, suppose segment C, even if it is shorter, segment C is suppose shorter than segment B, but it has some problem, it has some error, some technical glitch, something like that. So it'll push it down through segment B, which is network B. Instead of going through network C, it'll go to network B, which will end it up at router 2 because you've passed that network now. You have to go to another place. Router 2. Router 2 could have directly gone to say host C, but this path is blocked. This path is blocked, so it'll go to segment C, which is a network C, and which will forward it to host C. So host gets your packet based on the destination IP addressing, routing, and everything we've seen right now, all of those steps involved, right? So this is how it works. Now we're going to talk about DNS. DNS again not does not technically it's not technically lying inside the data network layer. Sorry, it does not lie in the network layer, but we needed to understand what you know how is this IP addressing exactly working. So what this is, sorry, this is called domain name system. It's very easy. What does the DNS do? So now, for example, I have a website and I want to access this website called www.example.com, right? So this is my website, and now I want to access it. I have to send a query, or I have to, send a query basically. So what DNS does is that it's a naming system used to translate these human readable domain names into IP addresses. So this is say 192.0.2.1. So what DNS does is basically this. It's like a phone book for converting these human readable. You can read what this is. You can see, okay, okay, this person is trying to access this website, example.com. It's human readable. But if I just put this, is it human readable? Do you know which website they're addressing if you do not look at the English, the human readable one above it? You can't, right? So DNS does this. DNS is um a system. It's sort of like a phone book where it helps the other each other identify the network, the human readable domain name we've given. So enterprises use this process to resolve names into the matching IP address. So it just matches the IP address. If the IP address, it basically defines protocols. DNS is so important. It defines protocols, and it divides standards for the text name used worldwide. It's really important because imagine having to understand, if imagine having to spend time understanding the IP address given, okay, www.example.com. This is stored somewhere in the somewhere, okay, and this is stored in, where is it stored? Somewhere it's stored in the domain name system. Right, imagine having, if it was not stored, it would have taken time to actually retrieve, you to actually understand the IP address, and then send the request, then route the whole thing and get the request, your answer back, get the website again displayed on your screen. That would have taken a lot of time, lot of effort, lot of power. So DNS just reduces all of that, and they work across the world together, forwarding queries to each other, right? So then now we're going to talk about address resolution protocol, which is actually in layer 3. So what it does is that, now we talked about DNS, right? DNS, how it's a phone book to understand, to convert those human readable queries to IP addresses. Using that knowledge as a base, we're going to understand address resolution protocol. This is a protocol, okay? It's and it is used in this layer. Okay, so what does this do? It is a method by which the host or router on a LAN can dynamically learn the MAC addresses of another IP or host router on the same LAN. So here we're going to talk about LAN, local area network. So ARP, this method is by which we can learn the MAC address. We can, here it is associated with the MAC address, not the IP address of another MAC address of another IP host or router on the same LAN. So what it does, it converts these IP addresses. It is primarily used to resolve the IP addresses into MAC addresses to communicate. So to communicate here, MAC, unique devices need to know the MAC address associated with the destination IP address. So what ARP does is that how before we were learning DNS, it resolves the human readable into IP. ARP does the IP into MAC. So that is what the same logic. What it does, it's basically a phone book for converting or for understanding the MAC translated version of the IP. Right? It's an IP to MAC address mapping system. Okay, and there's cache address. Everybody knows what cache is, right? Cache data is basically data, which is suppose if a good example would be, suppose if I'm on Instagram and I'm scrolling one reel after the other. So even I do that, there's certain amount of data which is stored, still stuck over here. That data, okay, which is stuck is called cache data, right? So we know what address resolution protocol is using the same concept. It's basically IP to MAC address mapping. Okay, it's used to resolve IP addresses into MAC addresses. Cool. Now we're going to talk about ICMP and also something which is known as ICMP and ping. Okay, this is the last topic. So what ICMP is, it is basically the full form of it is Internet Control Control Message Protocol. This is what ICMP stands for. So it is a network layer protocol used for sending error messages and operational information about network conditions. It is used to send error messages and network and operational information. Okay, so this is what I Internet Control Message Protocol. It's a very basic protocol. It is used to send error messages and operational information about network conditions. So if there is any error of if, or how the state of the network is, all of that is handled by the ICMP, Internet Control Message Protocol, and it sends a message, or it is used for sending error messages. Basically, if there's any error, this one reports. So what is ping? Ping here, what is ping? It sounds okay, something you're pinging somebody, you're telling somebody something. So it is a network utility that uses ICMP to test the reachability of a host or network. For example, if I am one host and we're testing, okay, okay, if this route, if this path is okay, if this path is okay, if this path is okay. So we'll use that. If there is any error, this ICMP will report, right? This is A and this is B. So what it does, it is uses this ping, which is a network utility. It will ping ki, okay, hi, or hello, good morning. So it'll send these messages, it'll send these pings. Obviously, it won't be hi, hello, good morning, but it'll be some data say. Okay, and what ping does, it is that it tests the network reachability of a host or network. It tests if this is actually working. Okay, this is not, the request has not been sent, or this is sending and this is sending, and it measures the round trip time for messages sent from the originating host to destination computer and back. So it needs to be a complete, it takes that's the runtime. It needs to be a complete cycle. Messages should be delivered, information should be delivered, and when the user pings a device, pings a device, it sends an ICMP echo request, and receiving device responds with an ICMP echo reply. So when you send, this ping sends an ICMP control echo request, and the receiver who gets this, it responds by an ICMP echo reply. Pretty simple. I mean, these are kind of, you might think, oh my god, huge words, but no. The concept, once you get it, it's pretty clear. So what does ping do? It determines whether the target host is reachable, how much time it takes for packets to travel, and if there is packet loss, if there is any packet loss. So that is what ping does. So ICMP and ping together test whether, okay, this path is clear or this path is not clear, and what error it's showing, what kind of how much time it is taking in all. It should be efficient as well, right? So what this is basically, ICMP is kind of like the backbone of this whole network layer. It tests path, or rather backbone of routing. It tests whether the paths are efficient, whether the host is reachable, and also if there is any packet loss, any error it is showing, it immediately reports back. And how is this done? Using ping, which is a network utility. So with this, we've covered a lot of topics. We also talked about DNS and ARP, DNS is basically resolve names into matching IP addresses, and ARP is IP addresses to MAC. We've also touched upon routing, how it works, destination IP address, and then that's how it forwards and it checks the routing. It does the path determination. So we've covered the network layer in brief, not too many details, but enough to understand it overall. So thank you.